Hello friends, today we will discuss the topic of interhalogen compounds. I am Dr. P.R. Malle, Head Department of Chemistry from led Bhaskar Raushikne Arts, Professor Narendra Gonde Science and Ashalata Gonde Commerce College, Sakarkheda, District Bultana. We will first look out the introduction. The binary compounds formed by the halogen among themselves are known as interhalogen compounds. The difference in the electronegativity value among the elements of the halogen family gives rise to the formation of these types of binary compounds, and hence the interhalogen compounds can be formed. There are the halides of electropositive halogens and are formed due to difference in their electronegativity value among the halogens. The general formula for the interhalogen compound is AXN, where N is equal to 1, 3, 5 or 7, in which the letter A is the halogen with low electronegativity, that is of higher atomic number, and X is the halogen with a higher electronegativity, that is of lower atomic number. The halogen A acts as the central atom with the odd number of X atoms which are covalently bonded, and therefore there are four types of interhalogens, namely AX, AX3, AX5 and AX7. So we will discuss about the formation of the interhalogen compounds. Due to the electronegativity difference, higher electronegative halogens attract the electrons from halogens with the lower electronegativity, and therefore the interhalogen compounds can be formed. Except fluorine, all other halogens have vacant d orbitals. So the electrons from sp orbitals get unpaired and promoted to the d orbitals, leading to the formation of halogen compounds. We will see some structure and bonding in the interhalogen compounds. First type is of the structure of the compounds of AX types. In these types of compounds, which contains one bond pair and three lone pairs, as this compound involves sp3 hybridization. Generally, the tetrahedral geometry can be shown by these type of compounds, but due to the presence of lone pair of electrons, the shape of the molecules get distorted and becomes linear. The examples of these types of compounds are ClF, BrF, BrCl and ICl. We can see here the pictorial representation of the linear ICl molecule, that is iodine monochloride molecule. Now we will see the structures of some AX3 types of compounds. These types of compound contains three bond pairs and two lone pairs. The compounds involve sp3 dehybridization. So the trigonal bipyramidal geometry is expected by this type of compounds, but due to the presence of a bond pair lone pair repulsion, the shape of the molecules get distorted and becomes T-shaped. Some examples of these types of compounds are ClF3, BrF3 and ICl3. We can see here the pictorial representation of T-shaped ClF3 molecule. We will now see the structure of AX5 type of compounds. These types of compounds contains 5 bond pairs and 1 lone pair, and therefore the compounds involves sp3d2 hybridization. As the hybridization is sp3d2, octahedral geometry is expected to be shown by these type of compounds, but due to the presence of lone pair of electron, the molecule get distorted and the geometry appears as the square pyramidal. The example of this type of compound are BrF5. We can see here the pictorial representation for octahedral and square pyramidal geometry of BrF5 molecule. Now we will see the last type, that is AX7 type of compounds. It involves the compounds which contains all the 7 covalent bond pairs with no lone pair. The compounds involves sp3-D3 hybridization. Only IF7 is the molecule of this type. The geometry of the molecule is pentagonal bipyramidal, and we can show here, we can see the pentagonal bipyramidal geometry of IF7 molecules. So this is the general information of the compounds formed by the halogens, and due to the difference in their electronegativity we can call them as the interhalogen compounds. So this is the small topic of the interhalogen compounds. Hope you will be satisfied by this. Thank you.